Welcome to Varun Techie channel. Share, like and subscribe. Today we will discuss natural language processing session 8. First we will see about match object. A match object is an object containing information about the result and the search. Note, if there is no match, the value none will be returned instead of the match object. The match object has properties and methods used to retrieve information about the search and the result. Dot span of returns a tuple containing the start and end positions of the match. Dot string of returns the string passed into the function. Dot group of returns the part of the string where there was a match. Today we will see about formal languages and automata theory. In that the basic concepts automata, automaton, finite state automata. First, regular expression is helpful in text searching. Any such regular expression can be implemented as finite state automaton. Regular expression is one of a way of characterizing a formal language called the regular language. Automata derived from the Greek word which means self-acting. Automaton is an abstract, self-propelled computing device which follows a predetermined sequence of operations automatically. If we take a rectangle, the three vertices are regular expressions, finite automata, and the regular languages. Finite state automaton are simple machines which could recognize the patterns. Finite state automaton has Q, sigma, small q, capital F and delta symbol, where capital Q is finite set of states, sigma is set of input symbols, small q is initial state, capital F is set of final states, delta is transition function. Formal specification of the machine is q comma sigma comma small q comma capital F comma delta. Here sigma and delta are symbols. It is not possible to write in the PPT, so I wrote as sigma and delta. Types of finite state automaton. There are two types of finite state automaton, that is NFA and DFA. NFA is non-deterministic finite automata. DFA is deterministic finite automata. DFA. With each input, one could easily determine the next state to which the machine would navigate. It is deterministic. It is to be understood that the number of states are finite with DFA. Next one, NFA. For particular input, the machine may move to any of the many states. So it is non-deterministic. We'll see in detail about the deterministic finite automata. For a particular input character, the output is deterministic and can go to one state only. Definite move to that state. DFA cannot accept a null value. Capital Q is finite set of states, whereas sigma is set of input symbols, and small q is initial state, capital F is set of final states, delta is the transition function. Now we will see an example. Here we are starting. The initial state is Q0. For Q0, if you give input 0, then it will again go to Q0. For input 1, it will go to Q1. And Q1 for input 1, it will go to Q1. For input 0, it will go to Q2. Q2 is the final state. Q2 on input of 0, comma 1, you will go to Q2 alone. For each input, we are getting only one output or the one new state. So it is deterministic finite automata. Now we will see about non-deterministic finite automata. Non-deterministic finite automata is similar to deterministic finite automata except the following features. The first one is null move is allowed. It can move forward without reading symbols. The second one is ability to transmit to any number of states for a particular input. The transition function delta can be written as capital Q cross in braces sigma union epsilon tends to 2 power capital Q. This is the transition function for non-deterministic finite automata. We'll see an example. First we are starting the first in the starting state is q naught or the initial state. If you are giving 0, you can go to q naught as well as q1. If you are giving 1, you can go to q1 alone. For q1, if you are giving 1, you can go to q naught. If you are giving 0, you can go to Q2, whereas Q2 can go to Q2 if input 1, and Q2 can go to Q1 with same input 1, and with 0 it can go only to Q2. Here for a single input you can go to multiple states. So it is non-deterministic. Now we'll see about transducers, an automaton that produces outputs based on the current input and or previous state is called a transducer. Transducer are of two types. The first one is Mealy machine. The output depends both on the current state and current input, and the more machine, the output depends only on the current state.